up, team? And welcome back to Herbs class, man, for 5 more minutes of math. So we've been having this factoring conversation for a while. We've talked about how to factor polynomials with 4 terms. We've talked about how to factor them with 3 terms. We talked about a few ways to factor them with 3 terms. But what about factoring with 2 terms? Yeah, we got a special name for that process. Well, a special name for that situation, I should say. Yeah, the difference of squares. And you know what I like to do. What better way to talk about it than to look at it? There we go. Now we're looking at a difference of squares. So before we start talking about a definition of why this is a difference of squares, let me show you that you can factor this using one of the old ways that we talked about. Remember the numbers game? Yeah, the numbers game. Remember, I'm looking for 2 numbers that will multiply to make this last number and add or subtract to make this. Oh, we don't have a middle number. But we do have a middle number. Remember what we put if there's nothing there? 0. Yeah, that's exactly right. So can you think of 2 numbers that multiply to make 49 and add or subtract to make 0? I can. Yeah, 7 and 7. And so now if I'm playing with the signs a little bit, I'm pretty sure if one of those 7s is negative, negative 7 times 7 is negative 49, and negative 7 plus 7 is 0. So I can factor this just the same way I factored everything else before. Yeah, just like that. Now, it could get a little bit more complicated, so which is why we're going to talk about another strategy to do this, to factor this difference of squares. Now, first off, let's talk about what the difference of squares is. First, make sure you're looking at an expression that has 2 terms. Check. Second, make sure each term is a perfect square. Remember what perfect squares are. Now for numbers, yeah, 1, 4, 9, 16, you know where we're getting them numbers from. 1 squared, 2 squared, 3 squared, 4 squared, yeah. And for variables, right, variables have to be even exponents. Remember from our exponent rules, this is a perfect square if I can divide that exponent by 2. Yeah, exactly right. Remember, so x times x will be x squared. Okay, do we have perfect squares here? Check. Okay, and then the last thing that we have to make sure that we're looking at is a difference. Yeah, of course, and you know what difference means. Subtraction. Yeah, check. Now, once you have all 3 of these things, it's very simple to factor a difference of squares. Watch this. 2 sets of parentheses. Step 2, square root of the first term in the front, just like this. Third step. And the square root of the second term goes in the back, just like this. And now the signs, 1 plus, 1 minus. Just like that. And remember, with every factoring problem, we can multiply this out to see if we get our original expression back. Ready? X times x is x squared. X times 7 is 7x. Negative 7x, those cancel each other out to make 0. Negative 7 times 7, negative 49. I think we got time for one more kick-up practice problem. Ooh, talking about kicking it up. Now, we're going to do these same steps. Let's check first. 2 terms, check. Perfect square, perfect square, perfect square, perfect square, check. Subtraction, check. Let's take some square roots. Square root of 25 is 5, and the square root of x to the 4th is x squared. Good. Same here, except 36, the square root of 36 is 6. Square root of y squared is y. 1 minus 1 plus, good. Now, when we start to talk about factoring completely, maybe once we factor this once, one of these expressions we factored into could be factored again. But that's a new video. Yeah, I'll see you over there though. Till next time, bye guys.